I'm actually excited. I'm actually excited for this episode. I like this episode.
So we have some follow up. We've got 3 bits of follow up
Yes.
I want to touch on. One is the Pentagon has killed the blimp project.
I am
Sort of.
unsurprised.
Well, I should say they have announced that they are going to submit it for like a review procedure, and in the interim, they will not be blimping around.
Yes. I mean, it should be clarified that I have learned in the days after the blimp incident, or the blimpsident, that the Pentagon had these blimps specifically not just to spy on Americans, but to actually spy on incoming missiles. So it did actually have somewhat of a justifiable, like, usable purpose. But still, why wouldn't you just, like, put radar towers up or something? Why use a blimp?
Yeah, well, the thing that I don't understand, I guess I could sort of understand it if it was in, I don't know, Alaska or over the West Coast. Isn't the Eastern Seaboard pretty like, who's going to hit the Eastern Seaboard?
Well, anyone going after Washington. That's why
Right.
it was there.
Right, but don't all of our hostile neighbors not have the range necessary? Like, isn't the only threat to us like China?
Maybe, but that's probably enough to get something through committee, to be honest.
But to defend the West Coast, I don't
No,
know.
no, no. I don't know, but I mean, like, but space technology has come a long way. I'm pretty sure. I mean, that's all missiles are rockets where you replace the humans with explosives.
Right, but I thought that the whole idea of space to ground missiles was kind of discarded in the sense of like, we really don't want to ship a payload up to space in the first place. It feels a little friendly fiery, or potential for friendly fiery.
I don't know. They felt like they needed to defend the capital, so they're defending the capital.
I guess. But yeah, so they've now deflated the blimps pending review. Well, I don't know if they've deflated the blimps. But they will be shutting down the program pending review, which could take up to a year, I think they said. And then who knows what will happen after that. But yes, apparently it was incredibly over budget and never worked properly, mainly because of software.
Oh, good.
So yeah, I know. It's like, oh, good. That relates to us then.
They're probably going to let all the helium into the atmosphere just to annoy you as well.
It is. Government contracts are really, or government software is really amusing. Just because it feels like there are a lot of high profile, nope, that didn't work announcements. I think probably the clearest is the healthcare gov stuff.
Yeah. I mean, I don't necessarily have a problem with that. You shouldn't, like, be afraid to try things and then fail. But it is also, at the same time, wasting a lot of money. But as we talked about last time, that's not necessarily a bad thing. I mean, it can have repercussions on the economy in other ways.
Well, it's funny because I said that with regard to like making tanks. With software, I'm not entirely as sure because so much of that is contract work. And government contracts are incredibly lucrative because the government doesn't know how software works, or at least the agencies that are hiring the contractors have no idea how software works. And so a lot of these consultancies will just bid ridiculous prices, and then so it's not translating to, oh, now we've got to hire 3,000 developers. It's translating to, we're going to pay like 3 developers a lot of money, and we're going to keep a lot of money. And I don't know, it doesn't seem like that has the same trickle down.
That's a good point.
No, granted, I have absolutely no idea about kind of military contracts in terms of manufacturing. So it could be exactly the same there. It could be that there's like one guy making the tanks and a whole bunch of C-levels, managing and taking lots of profits off of that too. So I don't know. I could be wrong.
Yeah, I mean, I don't know. I know software engineering is a fairly high-paid field, but it's not that much more higher paid than mechanical engineering, which would be tanks.
Well,
okay.
Well, right, yes, but I also think when you're looking at mechanical engineers that are making significantly more than 6 figures, you're looking at a relatively small percentage of them.
I guess the ceiling isn't necessarily high, but the number of people approaching that ceiling is lower in the field. I could see that. I could go along with that.
It is staggering though, the difference in salary for software engineers on either of the coasts versus anywhere else.
Yes.
Like orders of magnitude different, because cost of living. If you're a developer in the Midwest, you should be making $30,000. If you're a developer on the coast, you should start at $200,000. Obviously, because rent's a little bit higher, right?
Yeah. I mean, people in San Francisco are living in their cars because cost of living is so expensive,
right? And obviously, I'm exaggerating on that point, but it is far more than just cost of living changes. So yeah, I did also go ahead and follow up because I was complaining about NASA's cameras.
Yes.
And their lack of cameras. I did discover they use Nikons.
Yes.
For just about everything. And that up until 2001, they were using kind of all analog stuff, and now they switched over to digital, but they ended up with this big, huge Nikon contract, and so everything is Nikon, which I think kind of makes sense to me, because everything that I've played with that's Nikon is awful.
Wow.
And so, like,
there goes that sponsorship.
The fact that the fact that the camera works at all in space, all right, we'll take what we can get.
Wow. I mean, I've never used Nikon equipment. I had Canon equipment recommended to me when I was buying things.
Mm.
But, I mean, I went back and I looked at some spacewalk footage after we talked about this. I don't get why it's that bad either. I mean,
that's the thing. Like, I didn't just mention it because I was being snide about it. It was like, this really doesn't make sense. Like, it feels like this does not represent the technology that we've got up there.
Yeah,
like it was oddly bad. It wasn't just that it was bad. It was strangely bad.
So I looked at the article which you posted in the show notes, and I are those cameras specifically the ones that get like shoulder mounted? I saw like handheld ones that they used to take pictures of special things, but are those the live stream ones?
I couldn't find out. I did some searching. I probably could have done a bit more, but I couldn't find out exactly what was on the shoulder mounts. I did see that at one point they did go out there with a GoPro. I can tell you what I watched a few weeks ago was not GoPro footage.
Yeah, no, it absolutely wasn't.
But they had gone out there at one point with a GoPro and shot stuff. But from what I got from that article, Nikon does have kind of like an exclusivity contract with them. So, excluding the GoPro that happened, I would imagine that just about everything that they're using has to be Nikon in some fashion. Or Nikon has said, we simply can't supply this, so yeah, you can go ahead and get it from another vendor.
I mean, but that could suggest the cameras themselves are older than 2001 then, because that's when that contract would kick in.
That is true. Yeah.
That actually sounds like the most logical explanation to me. Those cameras are just older than 2001.
Yeah, no, that's entirely possible. I don't know. I should say I shouldn't be too mean to Nikon. I've heard that their lenses are phenomenal. But I've had to edit some footage. There were a couple of times at conferences, at video conferences, where I shot multicam stuff using a couple of people's cameras. Yeah. And I ended up using my lens on the camera, just a regular Nikon DSLR, and oh my gosh. Just what I got out of it was just terrible. It took me forever just to make it usable. I don't know. Canon is awesome. Support Canon
by buying cannons.
Cannons.
Firing things into orbit.
Oh man. So you've been entirely on Canon since you started?
The one camera and the one lens I own are both Canon. Yes.
Nice. Okay. Well, you've got a handheld or two, don't you?
Oh, that's true. I do have one of the Canon point and shoots that you told me to buy. I was like, Kevin was talking about a good handheld camera. What was it?
That is the Canon S110. I freaking love that camera.
And I've actually recommended that camera to another person who has bought one as well. So your recommendation has bought Canon 2 more cameras.
Well, and I actually bought a backup one.
Oh, wow.
No, because I think Canon has stopped manufacturing them.
Yes. There's a newer version, I think.
Right, there's a newer version, but it actually, to my mind, is worse. They updated... the glass, I think, is worse. The lens is worse. And they updated something. I mean, I can't remember off the top of my head, but I think it ends up taking slightly better still photos. But as far as just a really nice vlogging camera, the S110 was still kind of top of the line even after. And I think they've released another upgrade to it now, and it's still like, nope, S110 is the best. And so yeah, I wanted to have another one because I'm just like, this is perfect. I will say, you should get a wind cutter.
Yes.
Your little stick-on fuzzies that you can put in front of the mic hole, because otherwise, if you move the camera about, you end up getting wind noise and stuff against it. But that's going to be the case with just about any consumer camera.
Right.
But all in all, it is pulled better footage than I've been able to get on my DSLR sometimes.
I mean, is that in high light scenarios or something?
What's that?
Like, is that in high, like, large amounts of light scenarios or low light?
I've actually had to do pretty decently in low light as well. I mean, obviously, nothing that I've got is amazing in low light.
Right.
But it's held up against the DSLR, which is impressive. I mean, the reason, if I'm between using, I mean, I use a CinemaCam now for most of my stuff, but if I'm debating between the point and shoot and the DSLR, it's really just a matter of, do I need more manual control over the focus and stuff than the point and shoot will provide. Otherwise, I just use the point and shoot because it's awesome.
Yeah, I mean, I like the point and shoot. I have the color profiles and stuff on my DSLR that I like to use. So, I mean, that's kind of the biggest reason I don't use it. Right. And up until 4 videos ago, I was still doing all the recording on the camera. So I don't know if the point and shoot had mic input. If it did, it definitely didn't have the hot shoe for the microphone I was using.
Well, that brings us to another thing. You are making videos again.
I am. Yes, I've made 4 of them.
We'll put a thing in the show notes. Have you made your one for today? Because you're on a challenge now to make one every day.
Oh yeah, it's up.
Oh, good. Good for you.
Yeah, planned ahead.
I was nervous for you.
No, don't be nervous. When I have time to plan things ahead, it usually works out fine.
So what is the plan? What is the inspiration for this round of videos?
Oh, I went to Buffer Festival, which is a YouTube film festival that is held in Toronto, Canada, for the last 3 years. This was the 3rd annual one. And I went with a bunch of friends, and YouTube conferences always wind up being like, I need to make videos again. And this time I think it stuck. And I made a deal with a friend who hasn't made a video, I think, in like 2 years. He was there at the conference, and I was like, hey, if I make a video every day this month, will you make one video? And he's like, yes. So those were kind of the perfect storm to get back to YouTubing. So
is this friend just going to end up making a mashup of your month in review?
I don't know. It's up to him. Whatever he wants to put out, it will be his prerogative.
No, that's great, though. And so are you... I've actually been curious about this with your videos. Do you end up doing color correction?
No.
On your stuff? No. Okay, because it always looks like you tend to be... You are very well colored. I don't know what the term is.
So I have this weird thing. I spent like a couple hours one day trying to figure out what I was going to do to make my videos look good. When I moved into this apartment, and there's some cinema profile. I was looking for like good profiles to put on the camera that would make it easier to do color correcting, because I was thinking I should probably start doing color correcting. There is a profile for Canon cameras that theoretically sets all the inboard settings so that your raw files come out and they're ready to be color corrected. However, looking at that footage, it looked so much nicer than anything I was shooting before, and it looked perfectly fine. I was like, oh, I don't need to color correct this. It just looks good.
Oh, there you go.
I don't remember what the profile was called. I will look it up and send it to you so you can put it in the show notes.
I will do that. Yeah, no, I've shot on a DSLR for the first year, I think, of my stuff, and then For the longest time, it was just, let it do whatever it wants as far as color and contrast and all that stuff goes. And then, I mean, with I think just about all of the DSLRs that you're going to get, you can just set the color profile to neutral. You don't have to upload anything to the camera, and it'll basically just not start expanding out the highlights and the shadows, and it won't oversaturate things. You're not going to, and you're going to end up with something that looks very flat and weird unless you actually color corrected in your editor.
Yeah.
But so I've been doing that, and then of course the problem is then I have a terrible time trying to match footage between different cameras. I'm really bad at that.
I only shoot on one camera. I just move the camera around. In fact, a lot of the time, just to keep audio syncing, I just keep it recording and move it between like any different like tripods or something on the on the chances that I use different shots.
No, you gotta do that. The one thing that I find really frustrating about the DSLRs is that, and I don't know if this is true of yours, but it's certainly true of mine. It's true of a lot of kind of the lower level DSLRs. Is that the SD card format that they accept has a maximum file size.
Mm-hmm. Yeah, which I know the problem.
Generally equates to around 10 to 12 minutes of footage, depending. Now, of course, there are things about video compression that mean that a minute of footage is not the same size from one shot to another. If most of the shot is the same color, or at least close enough that the file can call it the same color, then it doesn't need to say, "Hey, these pixels were updated," and it can just go ahead and record the changes in pixels since a particular kind of keyframe where it does take a full shot. So you never quite know exactly when it's going to cut off. What the camera will end up doing is it'll stop and start recording again, and you'll lose a few frames in there. So if you're talking, all of a sudden it'll hiccup in the middle of something. I've lost a bunch of time because I would do that, and then I'd realize, something that I was in the middle of, I ruined it.
So I used to have it automatically resume. I do have that problem. I'm pretty sure all of Canon's like DSLRs that aren't made specifically for video have that problem. Mm-hmm. I do have that problem. And recently I've run into the same problem with my audio recorder because I have a lavalier mic that I hook into my phone to do the recording. And the only software I found that does like decent audio recording with like levels and stuff that I can use has a time limit as well. Luckily, the time limit is like the exact same as the DSLR, so I just have them set both to basically die at the same time, and I have two ways of watching it.
You're on an iPhone, right?
Yes.
You want to use Rode.
Rode? Okay.
Yes. Rode has an app that will do that. Because I had done the same thing. In fact, I still have an old iPhone that I occasionally use just to be able to record audio into, but it'll record kind of indefinitely, and then you can mess with all the settings, then you can automatically upload to Dropbox or any number of different things, and then sync things up.
Cool, because the top rated one I had found, it just it had horrible cutoff problems, and the levels you really couldn't adjust. It had perfect reviews with hundreds of ratings in iTunes, but it might have been, I have a pretty sensitive mic, I guess, and so it was not calibrated for it. I don't know. So I've been using GarageBand, but GarageBand lets you only record 380 measures, as it calls it.
Yep.
But it sounds really good.
Yeah.
So
that works. But no, I'll put a link in the show notes. Try out Rode because it did well for me. The only thing that I kind of struggle with when I record stuff to a phone is I'm always just terrified that I'm going to stop the recording midway.
I mean, yes. Most of the time I have the phone sitting on my desk and, the lavalier running up my shirt. Or that's what I've been doing the past 4 days. Because I don't stand when I...
Yeah, see, there are sitting vloggers and there are standing vloggers, and never the twain shall meet, right?
Right. So we have different problems. Although I did have a standing shot in today's video, but those are the very, very, very rare minority.
I don't think I've caught... I wish that there was some easy way to just say, lock this recording, don't let me do anything at all. But who knows?
I don't know.
So the last bit of follow-up that I wanted to touch on, I discovered that my brother listens to this podcast.
I discovered it as well when you linked it in the show notes.
Weird. And he called me out because we had a discussion last week about free will versus determinism.
Yes.
Because that's totally like a programmery thing.
It is. While waiting for your code compile, you can consider the whole of the universe.
Exactly. That's why software devs are so intelligent. We have so much time to think about these things.
Yeah, we're the new age philosophers, really.
No, but my brother called me out on the idea of optimistic determinism because I had said, and I actually caught this when I was listening back and editing the previous podcast. I was like, I did not say that well. That doesn't hold up. But I said something to the effect of that I find determinism to be more optimistic because there is the possibility that we could eventually know everything, and that to believe that quantum mechanics is entirely probabilistic and that there's no way to actually know anything deterministically is to ultimately give up on is to say that there's a hard cap to what science could achieve.
Right.
Of course, I didn't say it exactly like that. What I ended up doing is I said, and obviously science will never know everything, which kind of undermined my entire point. But I wanted to clarify. I think there's the idea of countable infinity and uncountable infinity. Mm-hmm. That the number of real numbers, 1, 2, 3, 4, is infinite, but it is countable. That is, if you had an infinite amount of time, you could list all of those numbers.
Right.
The numbers between 0 and 1 are not infinitely countable. Because if you had an infinite amount of time, you still couldn't get halfway there.
That's interesting. I've always heard. I haven't studied countably infinite well enough.
I'm also slightly parroting a Vsauce video.
Yes, because the way I've always heard it is that yes, the numbers between 0 and 1 are countably infinite, but because you now have a countably infinite number of countably infinite things, it's suddenly like another layer up, and therefore it's no longer countably infinite, because there's a countably infinite between 0 and 1, and the countably infinite between 1 and 2, and a countably infinite between 2 and 3.
The problem is that what is the first number after 0?
Well, I can't say. We'd be here for infinite amounts of time.
Right. So you can't even begin to start counting, given an infinite amount of time. So the idea is that that's uncountably infinite. So all that I still think that determinism is ultimately an optimistic way to look at things, because it implies that there is order and method to the universe, which we certainly will not ever have the requisite amount of time to discover.
Yeah.
But it does mean that, even if you can't count all of the numbers in the universe, you can find random ones that are very large out there. You can stumble across them and go, wow, okay, I know a slightly bit more than I did now. In a world where quantum mechanics does actually determine choice, there are things where you go, there's an entire area of understanding that it is definitionally impossible to know. And to me, I find that sad.
See, I don't look at it the same way. I look at it like we understand what the chances are of each of these. Now, we will never know which one it's going to be, but we understand that there is this probability, and that it could be the event A or it could be event B. And while we'll never know if it is ever event B or event A, it gives us, more things to look at rather than less. I don't know if that makes any sense, but it's like it opens all these like weird possibilities, that things that can happen that are like beyond what we would normally see, and these things that might normally get called as impossible but are actually just improbable.
Well, here's the thing though, is that I think that countable infinity is enough infinity to go around. I don't think we need to go, oh no, life is not mysterious enough.
But like, I don't know. Uncountably infinite things are also cool, Kevin.
They are. They're very, very cool. Like that number after 0. What was that? Remind me?
One is after 0.
So speaking of, well, in an article that may start to prove your point about quantum mechanics, NASA still hasn't been able to prove that we can't break the laws of physics.
Yes.
So defund NASA.
That is true.
There's an article about the hypothetical EM drive, and the idea, and I'm going to try and explain this. Alex, correct me if I'm completely off base on this.
Okay.
But if you imagine that you have a funnel, and you close both ends of it, and you take a bunch of marbles or beads, and you give them a bunch of velocity, so they're bouncing around the container, they are going to hit more against the big end of that funnel.
Oh, yeah?
And less against the small end. And so, the big end ends up absorbing more force, and thus the entire thing will move in a particular direction. Now, this totally is wrong, and doesn't make any sense because it is a closed system.
Right.
But the idea with this EM drive is that they basically do that. They have this funnel, and then they just shoot microwaves at it. And they go, hey, the area that was bigger absorbed more of the velocity, and look, now it's moving for some reason. This is probably equipment failure, but they haven't been able to say, they haven't admitted they haven't screwed it up yet.
Right. I think there's more going on than just marbles bouncing against the either end of the cylinder. But no one can find like mathematically consistent ways of describing exactly what that other thing is theoretically causing this unexplained amount of force to be, besides equipment failure.
Right.
So, like, the experimental physicists are all down in their lab saying, there's this clearly a force here. We can't find any problem or any way for this force to be coming from anything but this magic tube. And all the theoretical physicists are going, there's clearly no error in the math here. We can't find a way why you would have any force on this magic tube.
Well, and so, like, it makes sense if it's not a closed system, right? So,
right.
Like, if you imagine that you had let's imagine that I have a trampoline.
Okay.
And on top of that trampoline, I'm holding a paper plate.
Your neighbors must hate you.
Right. And you start bouncing ping pong balls. You start throwing ping pong balls into this system. The number of them that are going to hit the paper plate and send it up are fewer than the number that are going to hit the trampoline and send it down. Let's imagine that this is in space, so gravity isn't a factor here. Well, Theoretically, if we had a string between this plate and this trampoline, the string and the trampoline would eventually start moving downward because more of the particles would exert a downward force on the system than upward. The problem is that because these particles are all contained in this system, you can't do that.
Okay, so here's something fun. I believe they're using microwaves. And microwaves are fun because they're packets of electromagnetic radiation.
Right.
And so they have the fun little quantum effect of being both particles and waves at the same time.
Right.
Which does open up interesting avenues for weird explanations as to why this is working that, again, aren't mathematically consistent yet.
Right.
So it's not entirely correct to think of them as purely ping pong balls.
Right. But at the same time, in the sense of them operating and transferring momentum to the container, we consider them to their if I remember right, their momentum is based on actually the frequency of the wavelength.
Right. Yes.
But they still transfer momentum much in the same way that regular particles would.
Yes. I mean, that's when their particle properties kick in.
Right. So it's like a ping pong ball that sometimes becomes a note of music and then sometimes becomes a ping pong ball again. And when it hits the trampoline, it's like, hey, I think I'll be a ping pong ball right now.
Right. But what could be happening
at explaining scientific?
Yes. We are super good at explaining scientific problems.
So what is your take on this EM drive?
Okay.
Is this NASA is terrible?
No, this is not NASA is terrible.
Is this NASA should be really... Oh, we should also clarify. This is not a public press release. They've not made... They've not submitted any peer-reviewed stuff. This is... They posted on a forum clarifying... One of their engineers posted on a forum clarifying, we're still working on it, and we still can't figure out what the heck is going on.
Yeah.
But it's been
I think they
years.
are working on a paper. So I think they've already published one paper about it, though, but that was a while ago, right? So they published a preliminary paper.
There was... So this, I believe, originated in China, and the paper was somewhat questioned. And then NASA tried to reproduce the experiment and released a paper saying, nope.
Really? They came back and...
I'm pretty sure that there was that it was, and then there was another. Then they continued the attempt, and now they're confused.
Okay, see that conflicts with my internal timeline of
go ahead with yours, because I could be off on that. I could be confusing that with something else.
So yes. So China did. There was an experiment, but if I remember correctly, there was some earlier. It was before China conducted theirs. There was some earlier experiment by some other country or some other like crazy inventor or something, that prompted the Chinese to be like, "Oh, let's try to replicate this," and they were like, "Okay, this worked. Why the heck did this work?" Mm. And then NASA came along and did like a very like basic test. And instead of finding that it didn't work, they found that it did work. And then they were like, okay, we need to look further into this, which is why you have these further rounds of
I thought that
testing.
what I recall is that they did perceive this slight amount of motion that was predicted, but they ultimately said, yeah, it's because we're bad at measuring stuff. Like you can't have a system. It is so difficult to create a system that has no motion at all.
Okay.
No. This obviously doesn't work. It obviously has to be a measurement error.
Okay,
that's my understanding. Again, we don't work for NASA. We don't have journal licenses. We can't afford journal licenses. You want to support us? Send us multiple tens of $1,000s a year. I will gladly start reading all of the journals.
I mean, so would I. I'd gladly read this journal.
That'd be a lot of fun.
No, but I think you're right about that. I think they measured the force, but they were like, our equipment... I mean, this is within the equipment error.
Right.
I think that is what happened. So they didn't fail the experiment outright. They just said, well, we don't know why this would work. Our equipment's not good enough to tell. So, right, blah.
So they're continuing they're continuing the study.
They're continuing the study, and they have theoretically, if this guy on the forum is telling the truth, which I mean, he's a confirmed NASA employee, so. Yes, he very well could be. They haven't figured out why it's working yet, and they've improved the accuracy of their measurements.
Right, so they've filtered out more causes for conflicting signals, and it's still moving.
Yes.
And they don't know why. It's like you found a car that has no driver and no Elon Musk, and it's just moving, and you're just staring at this car, trying to figure out all of the reasons why it could be moving. You've changed the terrain so that it's not on a hill anymore, and it's still moving. You've removed the air from the system, so you know that there's nobody like blowing at it from behind, and it's still moving, and you have no idea why this car is moving. Right. You've removed the gasoline. I'm just running through all of the ways that you could.
Yeah, but now imagine the car is a copper tube. That's basically it.
Right, exactly. Well, no, so I'm curious. Do you think that this is a legitimate... So I mean, if this were to be the case, it would be huge. Granted, absolutely. The amount of thrust that it's been able to produce is tiny, 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 tiny. But this is a perpetual motion machine.
This is a perpetual motion machine.
Sorry?
It's not a perpetual motion machine. It wouldn't go forever.
It is. You're creating momentum out of nothing. You're creating something out of nothing. The benefit though is that basically it's like you have a rocket engine, you can just seal up the back of it because nothing needs to eject.
Okay.
Which is insane.
There is a theory, one of the working theories I've seen from people who believe that it's actually a legitimate thing, is that it's destroying information. and it's using the information and converting it to momentum. And that is what it propels on, because it doesn't violate like the total like conservation of everything in the universe, so it's converting from one thing to another. That is a far out theory I've seen.
Okay. I have to admit, I do not understand what scientists mean when they say information.
Nor do I.
I have no idea what they're... Like, information can't transfer faster than the speed of light. You can't destroy information. You can't... Information is preserved. Entropy, enthalpy. I don't know. I'm not... Like... So if I tear up this Papa John's napkin, I have... There we go. I've created propulsion.
I mean, so there was a recent discovery. Stephen Hawking was like, black holes will generate what is it? They allow information to escape. Like, they don't destroy information. All the information is preserved at their edge. So, like, when you throw your wallet into a black hole, all the information of your wallet is then distributed to the event horizon.
So if it's like Bitcoin, then that's fine. They can just verify the chain, and I can still use my wallet to buy stuff.
Yes.
None of the information is destroyed.
Right. Because I think that was one of the huge problems with black holes when they were first suggested, was that, well, this can't possibly work because they would destroy information.
Again, I don't understand that, because to me... Like, okay, like, if you consider light to be information, or you consider mass to be information, whatever, energy, all that happens is it's still there, it's just in a very, very small place. So, the information isn't destroyed, it's just irretrievable. It still exists. Yeah. So plus, the black holes still emit radiation.
Yeah.
So maybe radiation. They're just, like, transferring it in a different... frequency. We need to understand what information is. We'll have to have a follow-up in the next episode after we've studied. We are two computer scientists who have no idea what information is.
So remember how we were talking about last week, how there is no good online physics stuff? This is what happens when there's no good online physics curriculum.
Well, no, the thing is that there's a lot of great online physics stuff. It's just very isolated. It's like Minute Physics or various channel ASAP Science or whatever. And there's a lot of really cool stuff that you can go ahead and you can find. But when it comes to like, here's a specific question I have, and I need more than just like a, hey Reddit, give me the 5-minute explanation of this. Like I don't know where to go, which makes me sad. I partially blame academic journals for this.
Yeah, that's true. I mean, I wonder, I have no idea. Do you have the same problem with like chemistry and biology and stuff?
Yes. Okay. I have the benefit in biology that I have contacts in biology that I can be like, I have a stupid question. How did sexual reproduction start if everything started off as just mitosis? Doesn't make any sense. Is that irreducible complexity? And then they're like, no, actually there are the species that do both asexual and sexual, and so you can slowly get there, and it does provide an advantage. I was like, oh, that's genius. Because my concern is like, okay, if you're the first organism that's like, hey, I like sex, and everyone else is all busy being asexual, how do you ever reproduce? To me, that's a problem. Like, it would have to be the case that two random organisms suddenly decided they like sex at the same time, within each other's lifespan, or sex couldn't happen. And then they're like, no, you could. There's a both option, so you can be like, I really like sex. It just can't happen for a long time until someone else decides they like sex too. This is.
I took biology for 1.5 years in high school and haven't really thought about it since. And so this question has never like even floated through my mind.
It really, really bothered me. Because you think about it, like, you've got those single-celled organisms, they didn't reproduce sexually. It is an advantage to reproduce sexually because you're sharing chromosomes, and so there's more opportunity for diversification and resistance to diseases and stuff like that. But if we slowly evolve, the first person who is capable of sexual reproduction, if nobody else is, what happens?
It's like quantum tunneling.
Right? No, it's not. It's on the macro scale.
You
You can't quantumize everything out.
No. But it's like you have a preferred state that's through a wall, and the wall is having more than one sexually viable partner. And so you just borrow energy from the universe and jump through the wall, and then you wind up in the preferred state.
No, but it just, I don't know. It bothered the heck out of me. Because to me, like, because that is the whole thing about evolution, is that if you can find something that you can't get to through baby steps, then evolution doesn't work.
Yeah.
Or at least it doesn't work without some very, very, very long odds against it. If we were a legless society, the chance that one person would randomly develop a leg is very, very, very slight.
Yes.
Like longer than the age of the universe slight. So that was the thing that bothered me. But it was cool. I was able to call someone up, be like, hey, I'm having an existential crisis here. I think evolution has to be all wrong because of this thought that I had. Explain this to me.
Yeah, I wish I knew a theoretical physicist. I do not, however. They'd probably be very annoyed and wouldn't be my friend for long. But
Right.
yeah, I don't know. I mean, if we delete this podcast, is information lost? Like... And then we can power our spaceships by creating and deleting podcasts? Does that work?
That's
I
brilliant.
Think so.
Podcast-driven, podcast-driven space travel.
Okay. I guess going back to the original question of whether or not I think EM Drive makes any sense, I'm giving it internal, like, my internal belief system is 51-49. I have 51% confidence that this is going to work, and we're gonna do this, and it's going to change everything.
Okay.
And then 49% chance that no, this is just some stupid thing, a loose cable somewhere.
I'm 51% on perhaps the Alcubierre drive.
Yes.
I'm about 51% on that. On this one, I'm like 95% sure it's BS. Like, no, this doesn't work. Totally doesn't. No, doesn't make sense.
See, I'm totally open to there being things about the universe that we have no idea how they work yet, and it's these breaking changes.
That's not what I said. I'm not saying we know everything about... Kevin Giese has said that we know everything about the universe and how it operates. I'm saying that in this particular instance, I think it's BS. I don't think this is legitimate. I don't think it's going to pan out.
Okay,
I think that they're going to discover, like, oh... We have an intern that was sneezing in the chamber where we were testing this thing, and it threw off the results. Like, that's what's going to happen.
The intern is sneezing in a vacuum.
Exactly. That's exactly what's going on here.
If an intern sneezes in a vacuum and nobody hears him, does it still make a sound? No, but okay. I should say I'm optimistic that this is something we don't understand, and it will broaden our horizons in many ways. I'd rather believe that this is real than it's not real. Until proven otherwise, I'm going to believe that way, if only very slightly. Because, like, not only does it allow us to build spaceships that could, like, go places in reasonable amounts of time, it also means that what we know about physics is wrong in some way. And maybe just making this tiny little change to some part of physics, like how exactly conservation of momentum works, or how conservation of information, whatever the heck it is, works. So making some tiny change to that could open to the door to, like, further discoveries and further things.
I'm totally on board with you on all of this. Just not about the part of, hey, look, conversation of momentum isn't really a thing anymore. Like, I'm totally like, yeah, keep studying it, try and prove it wrong, continue to prove it wrong until you give up or do prove it wrong. Because that's how we do all science. I mean, try as hard as possible to make something not true and eventually give up. Like, that's...
So here's what happens, though. There's this very obvious experiment you can do. Eventually, you get to the point where we haven't been able to disprove it yet. We need more money to conduct the ultimate test. And that is build a spaceship with this engine, put it in space, and see if it works.
No.
If it works, then it's awesome.
No, the problem, though, is that the amount of thrust that they're getting out of this thing is so minuscule that solar radiation would vastly overpower. Like, being in space is not going to be a legitimate test.
No. Like, you just need a small nuclear reactor. You just stick a small nuclear reactor on the thing. You throw it in space, and it will give you, like, over a few months, I think, probably even less scale. I was looking at some math. It will get, like, significantly faster than the solar radiation would ever push it. Like, it's you can prove this by building it and putting it in space.
You can disprove it. You can't prove anything.
Okay.
Nothing is provable, Alex. Nothing is true.
Okay. You can disprove it by building it and seeing if it doesn't work.
Right, exactly. We could spend tons of money. We can throw up fissile materials by lighting a bomb underneath them and put them into the atmosphere, and then let the thing sit out there and wait and see if it does anything. And the longer the time ticks on, the more we will know that, nope, this is total BS.
I mean, if you have a solar sail, I think you're reasonably right that the solar radiation would overpower it.
And we do have solar sails.
Yes.
Which is,
yes.
so I'm like, not this, that's not an argument, that's just also an observation. And it's really cool. Solar sails are awesome.
Yeah. I mean, but the size of the device we'd be putting out there isn't that big. So the solar radiation is fairly sparse. You need a really big sail to get any real amount of thrust, right?
I would still be nervous. I guess obviously it's going to depend on where you end up putting it, but I would be nervous about the effect of high velocity particles in space actually colliding with it that we just can't register.
Okay.
I mean, I could be, I don't know. I don't know. I don't work for NASA, so I don't know. I would still say that even if you brought the thing out there and it did start moving at a snail's pace, there would still be a lot of questions as to maybe there was a tiny rock that dinged it at one point and we missed it.
Okay, so here's the thing about constant acceleration. So the original Chinese tests suggested that they could get 750 micronewtons of thrust using 2.5 kilowatts. Mm-hmm. For reference, some people's computers use 2.5 kilowatts. Your microwave is probably about 1 kilowatt, 1,000 watt microwave.
So if you wanted to send your microwave to space,
yes,
this is how you do it.
But so now let's scale that back. So China got theoretically 750 micronewtons.
Right.
If theoretically you could get a 50 micronewton thrust on a craft that is like sustainable. So that's like a fraction of the power that your microwave used. And you could theoretically do this with a solar panel.
Right.
A fairly small solar panel. You'd start pushing your craft. It depends. I'm not sure what weight they're using for this calculation.
Oh, you actually get a calculation? Okay, I'm excited.
Yes. Okay. So here's a calculation. So you have 50 micronewtons of thrust at some mass. I wish I knew the mass. I
think we're going to have to change the podcast name to like Space Code Monkeys or something.
Maybe. I don't know. The point of the matter is, even with that small amount of thrust, in half an hour you could get something going a meter per second.
What?
Yes. Yep.
What?
And then in a day, you could have it going 40 meters per second. Like, constant thrust is, like, huge over long periods of time.
If you're propelling, like, a stick.
Yes.
But
how big are these things?
That is kind of the big question as far as that calculation goes. If it's like, we could propel the shuttle by a meter per second in 30 minutes, that would be awesome.
Yeah, it's not going to be that.
That would end up. I would argue that because you're dealing with those low velocities, with things like docking maneuvers and everything, that all of the orbital maneuvers that we're doing would eventually just become powered by this system.
Yes, absolutely.
No more fuel to dock with the ISS because really, they approach. I think it's something like half a centimeter a second is the docking speed for the ISS, something along those lines.
Yeah. It's very slow when they get right down to it. That's just to help protect
right. Well, because if you lose a paint flake and it comes around and all of a sudden you've got gravity, which you haven't seen, Alex.
Yeah, I know. I know.
Need to get on that.
Maybe I'll watch it this weekend or something.
You should. I mean, it's not great, but you should.
I mean, yeah, it's been on the watch list. I have it. Like, I want to watch it. It's just, I got busy doing other things.
Yeah, fair enough.
All right. What I've realized is that I need to sit down and actually do my own math to figure out exactly how big a ship you could power.
Well, we can figure this out. We've got micronewton. So it's how much? 750 micronewtons?
Yeah. 750 micronewtons, but I don't know the mass of the thing is the problem.
Right, but we could assume what's the mass of the space shuttle?
Okay, it's not going to be the size of the space shuttle. These things are pretty small.
No. But I want to know how fast we can propel the space shuttle.
Okay, we can find out the mass of the space shuttle. That is things. You're going to have to do so much editing for this podcast.
I will do that. It's your classic rocket equation, bringing it up.
Okay, it is massive space shuttle.
Oh, hang on. The rocket equation isn't going to work here because you're dealing with a starting mass and ending mass.
Yeah, that's true.
Damn it.
You don't change anything. Percent mass versus time. Oh, yeah, the space shuttle mass changes, by the way. What is its landing mass?
No, we're not. No. Can't go landing mass. That's like, let's throw everything off of the thing before we land. No.
Well, that's all the fuel. You don't need the fuel anymore. You just use a beamed power.
No. Take the orbiting mass.
Orbiting.
Well, okay, so yes.
Orbiting and landing mass.
The Newton represents the amount to accelerate 1 kilogram at a rate of 1 meter per second squared.
Yes.
Right. So we've got
Payload.
750 micronewtons.
The space shuttle is approximately 2 million kilograms.
Okay. So let's see. So Newton equals wait, sorry. No. It's mass times acceleration. What am I doing? Force equals mass times acceleration equals mass times acceleration. We know the mass. We know the force. We want to figure out the acceleration. So acceleration equals force over mass. And 750 micronewtons is how many newtons? Google.
I should note that NASA got only 50 micronewtons, which is why they were using that particular. So if you want to go with the Chinese number of 750, or the
we'll go. Well, I will grant you that one. So 0.00075 divided by the mass of what did you say? 2 million?
Yeah, 2 million kilograms. It's a little bit more, but it's just point.
All right, so that's 3.75 times 10 to the negative 10, and then it's the integral of that to get. We want to set the integral of that. So integral from 0 to ending time. So
how long do you want to go?
Integral from 0 to t. This is just to get up to 1 meter per second.
Oh, okay, cool.
Is going to be 3.75 times 10 to the negative 10 t. And I'm just going to let... Oh, shoot. What's the website? Wolfram Alpha.
Oh, yeah. Absolutely.
Because...
Why has no one else done this math?
We could do science.
Oh, I know. I'm just surprised that no one seems to have...
I also love that I can just say random things to Wolfram Alpha and it knows what I mean.
Yeah, no, Wolfram Alpha is amazing.
Wait, what? Hang on, now I'm confused. Solve for T. I'm not going to bother plugging it in. You plug it in, Wolfram Alpha. Oh, right, I can't use T in both. Right, I'm going to say from 0 to...
Oh, you're trying to use the same variable twice.
Yeah, from 0 to s, 3.75 t dt, solve for t. The acceleration is 3.75 times 10 to the negative 10 t dt. We want to integrate that because we want to get the total area under the curve as it's accelerating.
Right.
Right? And we want to find the point where that integral equals... I'm sorry. Yeah, we're not solving. I was trying to plug 1 in for t. I want to set 1 equal to the integrated expression. Oh, man. This is what happens when I haven't done calculus in like too many years, and then all of a sudden I start doing KSP stuff, and I'm like, nope, need to do it now. All right, so it's 1 over 1.875, 10 to the negative 10 equals t squared. So it's the square root of 1 over 1.83. Okay. Let's solve that. All right. So that is 73029.7 seconds. 1217 minutes. Divided by 60 again. 20 hours.
Yeah.
Okay, so there we go. It's done. If you're able to get 750 micronewtons of thrust, it would take 20 hours to reach 1 meter per second.
With a space shuttle.
With a space shuttle. Yes, but that's not... You're saying that like it just proves my point. It's still freaking tiny.
Okay. Not really. Have you been in a space shuttle?
They're
pretty big. Yes. I mean, I've been to Cape Canaveral a couple times. They've not been flight certified space shuttles, but they have one you can walk around in.
Yeah.
They're not small things, Kevin.
No, they're not small things.
They're quite big.
But it's also not like, oh, well, okay, I'll just head out there in a Mini Cooper or something. I'm not going to go spacing in a Mini Cooper, Alex.
Right.
You're still dealing if you're looking at this as a replacement for a lot of thrust, you're still for a lot of what we're currently using traditional rockets for. You're still dealing with orders of magnitude of mass on that scale.
I feel like we didn't take this far enough. Because
you do the calculus this time.
No. I was just curious what you solved for 1. So you got to 1 meter per second. How long would it take to get to 0.5 C? Well, not 0.5 C, but 0.001 C.
Square root of this divided by 1.875 times 10. Man, I'm typing this into Google and not into Wolfram Alpha. Rookie mistake.
I'm sorry. I need to know how long this takes to get to the
times 10
fraction of the speed of light.
The negative 10. Well, because that's the highest we've achieved thus far, right?
The speed of light? No, we're not even.
No, 0.01 of the speed of light. Wait. You want to know how to get to speed of light? How long it takes?
0.01.
Okay. 0.01. Change this out. No, because we are at 0.01, aren't we? Didn't we calculate it in a previous episode? One of the is it Voyager?
Maybe. I don't know. It's a fast thing. Relatively doesn't even kick in. It's going 15.73 kilometers.
Let's see. 1.26 times 10 to the 8th seconds. Divided by 60. Divided by 60, because I'm not even going to bother with minutes. Divided by 24. Divided by 365.
Survey says
4 years.
4 years. That's pretty good.
And to get to the actual speed of light.
Is it set up now so we can just enter arbitrary meters per second values?
Yes.
Okay.
Wait, 40 years.
Yes. That's where it comes in handy. Aha. Aha.
Damn it.
I've won. We can get the space shuttle to the speed of light in 40 years, baby. And then it doesn't matter. Then we could go anywhere. That's not taking into account relativistic mass increases.
Dang it. All right, fine. This would be cool. But also, okay, no. Now you have to look up what the thrust is for solar sails.
I mean, the problem with solar sails is that once you get too far from the sun...
That's still true of this. You need to be able to produce the microwave radiation.
Yeah, you can use RTGs. 2.5 kilowatts isn't that much. Okay, radiothermic generators, RTGs. I feel like we should clarify. They basically use plutonium, which decays and generates heat, and they use a special little electronic thingamadoo-dad. I don't remember what it's called. which uses the differential between hot and cold to generate electricity. And so by having this hot thing in the middle of cold space, you have this temperature differential, and you can generate electricity.
We should also mention that Voyager spacecraft will be shutting down in a few years because their RTGs are defunct. Their solar sails wouldn't be, by the way, Alex.
Yes, but you get away from the sun.
But no, all I'm saying is that the RTG is not going to be this is how we continue to power this thing forever, indefinitely in space.
Okay, so here's an interesting question.
Because it doesn't matter how much, how many megawatts the thing takes to generate the microwaves. The RTG decays at a constant rate, regardless of whether or not we're using the electricity or not.
Yeah, that's true. So here's an interesting question. At the speed of light, your relative time is nothing, right? So no time passes for you. So your RTG doesn't decay.
No. This would be a great time to have a guest on. You want to explain how RTGs operate at the speed of light with the EM drive? Call in now. God damn it, Alex.
Okay, I do have an answer for... So if you have an 800 by 800 meter solar sail, you get about 5 newtons at Earth's distance from the sun. Yeah, 5 newtons.
Right, so Alex, remind me, is a micronewton larger or smaller than a newton?
Much, much, much smaller. The point still stands that that's at like Earth. So at Earth is really close to the sun, relatively speaking.
Right. And you're dealing with the inverse square law. So the further you get, the amount of sunlight that you get is square root of that distance, that scaled to some proportion. So the amount of sunlight drops off faster than the distance that you are from the sun.
Right.
So there is a point where yes, the amount of sunlight that you're going to get is not much.
So just to put this in perspective, it's there have been some teams that have done the calculations. And
then why did we have to go through all of that, Alex?
No. For the solar sail, okay. People have done much more math on the solar sail.
That's because it's real.
Yeah, but not as cool, and maybe just as real. Maybe. So it seems to be capable of going about 0.1 C, realistically, for getting to like interplanetary travel.
Within what time frame?
I'm not sure.
Because that would take 12 and a half years for the EM drive, Alex. Even using China's estimates, which were 15 times that of what NASA got.
Yes, however, that's just a little... I don't know how big that experiment was. It was probably like an engine you could pick up. So yes, with a rocket engine you can pick up yourself, you could hit that. So they'd probably use a bigger one that would have more, maybe like a whole newton of thrust.
It's going to require more power. A lot more power. You got to pump a whole lot more. You got to get a whole lot more microwave ovens up in that thing.
Yeah.
Like all the hot pockets.
Okay, so here's the thing. It would take, going at a tenth the speed of light, it would take 42 years to get to Proxima Centauri. So it doesn't really matter how fast the light sail can accelerate. To get to the nearest one, it's still 42 years, which is about the same time it takes for the EM drive to get to light speed. And light speed is basically equivalent to anywhere.
So we've been doing all this whole ignore relativistic speeds. Refresh, I'm going to say the audience's memory, but I'm really going to mean my memory. So let's say, you get the EM drive hocus pocus that doesn't work, but you're going to say it does. And you get to like half of the speed of light. You go to Proxima Centauri and come back. What has happened to me laughing at your fake technology in the interim, and what has happened to you flying around on your fake technology?
I mean, I've done nothing and you've died, basically.
Okay. How long ago have I died? Unimaginably long time, right?
I mean, it's time dilation is calculated by the square root of 1 minus v squared over c squared.
Thanks.
Velocity.
That's helpful.
I mean, yes, it is helpful because now you know how to do the math.
I have already done plenty of math for this episode. Thank you very much.
Kevin is the math master of today's episode.
Yeah, but I'm just trying to think. So, the problem though is that basically, unless all of us go to Proxima Centauri at the same time, if you go to Proxima Centauri at light speed, does it even matter? Does anybody care? Like, is it other than you? Like, who cares?
Does it even matter? Okay,
well, no. So, just kind of a little thought experiment. That if, we got to light speed and you went over to the Andromeda Galaxy and hung out with some aliens and came back and we'd been dead for trillions upon trillions of years, why did we invest the money sending you over there?
Because I would have a good time.
Right. No, the question that I have is there a point where the addition of speed doesn't actually buy us any net gain because the probability of us reaping any benefits from the information transmitted back is so low? Do you know what I mean by that?
Yeah, I mean, yes. I mean, so here's the thing. Relativistic effects don't really start kicking in until half the speed of light or something, or not really even noticeable.
Okay.
They're there, and on longer missions, you could calculate them.
The atomic clocks up on satellites do get thrown off, and we have to account for that with GPS and stuff like that. It does exist, but that's accumulated over time.
Yeah, and it would be the same thing until there's some point where it really starts to take hold of things, and it's past half the speed of light. But so even going at half the speed of light, you could get to the nearest star in 10 years.
Right.
That's cool.
But I guess the question, and this is part of just because I have not paid enough attention to this in a recent enough amount of time, you can get to the star in 10 years, and if you start transmitting stuff back to us immediately, that's 10 years plus whatever relativistic stuff happens in that interim.
Right. Yeah.
So if I send you, Alex, to go explore the nearest planet, it's at least 10 years from the time you get to the planet for me to figure out what you saw. What is the additional amount of time from my perspective of you traveling out there? Are we talking thousands of years? Or are we talking 12 years?
No.
Because it's at least 10, years. Right? If there's no relativity, then it's 10 years for you to get back and then 10 years for your message to get to me saying you arrived.
Okay, so here's the thing. Alpha Centauri is 4.3 light years away. So that's how long the message of me saying, "Hey, I got here, I got back," would work. Which is why I was saying if you're going half the speed of light, it takes you about 10 years.
Right.
Relativity
so
really
for you, it takes you 8.6 years to get there, and then you would transmit a signal, and so that's an additional 4.3. So that's 12.9 years. Now that's ignoring relativity entirely. Now the problem is the relativity of during your travel means that it's taking me more time while you're traveling.
Right.
And I'm just curious, are we talking from my perspective, it's 15 years since I got your okay message? Or is it I've died and my children have died and the sun has exploded?
Oh, no. It's 11 or 12 years.
But no, because you're at 12.9. It's not less than 12.9.
Okay, so it's not. It is. I'm.
Is there a relativitycalculator.com or something?
There probably is. Let's Google that rather than try to do this. I'm sure there is. Here we go. Time elapsed at the observer velocity. Okay. Relative velocity ratio to light. Okay, so you're going 50% the speed of light. This website doesn't work. Good.
Oh my god, Wolfram Alpha has a time dilation calculator. Alex, which of us is the rest frame and which of us is the stationary observer? Oh, I'm the stationary observer.
Yes.
Okay. Right. Okay. So time and rest frame. So for you, it has been. So your travel out there took 8.6 seconds, and your speed is
Seconds?
no, dang it, 8.6 years, and your speed is half of the speed of light, which is half of the speed of light. Okay.
All right. I'm doing the math.
No,
I'm doing.
I've got this, man.
All right. I've done the math. I've done the math as well.
Okay. All right. What is your answer?
Okay, so for my traveling at 8.6 years in a spaceship...
At half the speed of light.
At 50% C, you would experience 9.9 years on Earth.
That is what I got too.
Hooray!
Yay!
For consensus!
What service did you use? Or did you actually do the math?
I did the math.
Oh, look at you. See, Wolfram Alpha, I literally just Googled Wolfram Alpha time dilation. You could type time dilation into Wolfram Alpha, and it's just like, yeah, plug in the stuff you want to know.
Or you can just know that T equals T0 over square root of 1 minus V squared over C squared.
Yes, it also tells me that on Wolfram Alpha. So you don't have to remember that either.
Well, whatever.
So, yeah. Wolfram Alpha is just awesome.
Yes.
Not the least for just its text recognition in terms of actually figuring out what it is that you want to know. Like I can say in human language, integrate from 0 to t and then some equation and not form it well. I can say the text square root. I don't have to type in SQRT or whatever. And I can just roughly give it a sense of what I'm trying to ask and it'll do its absolute best. And generally it is remarkably accurate. There's a lot of like neural net stuff going on there that's all sorts of crazy.
Yep.
So, okay. So if we got you to half the speed of light... Back in 9.9 plus the 4.3 years of light speed for you to tell me you got there safely.
Yep.
During which time I would be worried sick for you, not least because you are traveling on a.
I mean, I can be transmitting the whole time.
That's,
like you don't
no turning on your headlights while you're going half light speed. We're not doing that. We're not doing the math on that. We're not. But okay, so no, you're going to maintain radio silence because we don't want to have to worry about the calculations.
Okay.
So the problem is getting up to 0.5. So it's more than 4. If we were, let's just say that to 0.5 was 4 years. Let's imagine some vehicle for which the thrust was higher.
Okay.
You're still talking about 4 years during which you're traveling and not at 0.5 the speed of light.
Right.
And then time when you're trying to slow down, so you're also not traveling at that speed.
Yes.
So there's a very big portion of that trip that is stretched even further just because you're either accelerating or decelerating. Right. So it's still pretty challenging. But we still have to deal with a lot more available thrust if we were to look at this as something viable. But it is cool that we're able to have the discussion.
Yeah, I mean, and again...
So I will give the EM drive props for that.
Yes, the EM drive is amazing, and I have a slight belief that it works.
I have a belief that it is a wonderful thought experiment.
Within 10 years, we'll know. We'll have an anniversary podcast.
All right. We're totally not going to have any idea in 10 years, but I will join to gloat at you.
People are building, literally, like people on the NASA space flight forums are fundraising and building a Pico satellite to put a EM drive in orbit.
What? Why? What?
That they're building, like, you know those little CubeSats that anyone can buy? Mm-hmm. They're building an EM drive into a CubeSat.
On a related note, why don't we have a CubeSat?
Because money?
We've got Raspberry Pis. Let's do this.
So the cost
I'm pretty sure it was only something like $10,000. Like I say, only something like $10,000. Like that's a huge amount of money.
Cheap,
but that's like a car. It's not. Yeah. It's not like Branson money.
No, not at all.
It's not this like ridiculous. It's the sort of thing where if you're presuming that you're in the middle class, you could save up and decide that this was something you wanted to do.
Yeah.
Yeah. That's pretty cool.
Yeah.
We should do it.
Okay, I will. Each of us in proportion to their disbelief in the CubeSat. And
I believe in the CubeSat. No, the CubeSat is real. Alex.
I don't. Are you sure? I don't know if I'm convinced yet.
Oh man,
EM drive definitely exists. CubeSats. I mean, that's stretching it. Like, you can't really get things to space that cheap and small and cubicular.